This is the 8th lecture in the first semester Java course presented by Savage River Research. To view all of the currently available lectures, point your browser to savageriverresearch.com and click on Open Courses. And this is what we'll cover in Lecture 8, dialog boxes and wrapper classes. But before we begin Lecture 8, let's review the solution to the programming problem presented at the end of Lecture 7. And here's where we were at the end of Lecture 7. This is the problem description. The graphic shown is a right triangle, which means that the side opposite the right angle, which is the longest side of any right triangle, is the hypotenuse. And the square of the hypotenuse is equal to the sum of the squares of the two legs. So if leg A is 4 units in length and leg B is 6 units in length, then we can find the length of the hypotenuse squared by setting c squared, that's the hypotenuse squared, equal to 6 squared plus 4 squared, or 36 plus 16, which sums to 52. And taking the square root of both sides of the equation, we get the hypotenuse, c, equal to the square root of 52, which is about 7.2. So to code the solution, we're going to have to square two numbers, then sum them, then take the square root of that sum. Now, in Lecture 6, we looked at the math class in the Oracle Java documentation to find the constant pi. But we can also get the details for pi from Eclipse's help screens by hitting Control Space while the cursor is just to the right of the period that follows math. From there, we can get these help screens. And once those are up, we can scroll down to POW. That's short for method power, which allows us to find the result of raising any number to any power. And squirt, SQRT, square root, which allows us to find the square root of any number. So all we have to do now is declare variables to hold the value for c squared and the hypotenuse, and create a scanner object, making sure that we have first imported the scanner class. Now, ask the user to enter a value for the first leg. And note that this time I chose to declare A as a double variable on the same line I called the scanner method, next double. Alternatively, I could have declared it when I declared c squared and the hypotenuse. Now, we'll get the second leg, then use method POW to square both values, then sum them to get c squared. Then use method square root to get the square root of c squared and assign the result of that calculation to the double variable hypotenuse. Now it's simply a matter of outputting the result and closing the keyboard object. Now, take a look at this. Once again, I'm going to put my cursor to the right of the dot that follows math. We could use math.squareroot or math.power, and we'll get the same two help screens that we saw before. Now, slide down to hypot for hypotenuse, and read the description for method hypot and consider whether or not you can reduce these 3 lines of code to one line. Do you see how we can reduce lines 16 through 19 to one line, this line. Method hypotenuse will do all the heavy lifting. All we have to do is pass the parameters. The parameters A and B, which contain the values entered by the user. Method hypot will calculate the hypotenuse of a right triangle having those two values as its legs. And system.out.println will append that value to the string hypotenuse space equals space, and the result is identical. But note that I now have light bulbs on lines 6 and 7. And if I put my cursor on either one, Eclipse will tell me that the problem is that the value of the local variable, c squared in this case, is not used. So now I can get rid of those two lines of code. So altogether, I get rid of 4 lines. But now the obvious question is, how could you possibly know that a method like hypot existed? Well, you couldn't, unless having studied the problem domain, you determined that it required some calculations, and then either did the control space trick to open the Eclipse help screens, or opened the Oracle Java documentation to this page. Now, from here you can scroll down to Method Hypot, then click here to get the details. Now, if you're having problems getting to this screen, go back to Lecture 5 and review slides 65 through 106, because the math class, that's math with a capital M, can be somewhat difficult to locate. But if you're coding a mathematically intense problem domain, you need to first understand the problem, then page through the math class to locate any appropriate methods. Faced with a problem involving hyperbolic cosines, you definitely don't want to code your own method to find the hyperbolic cosine of x when the method is right here. Well, that's all well and good, but I'm certain that it has occurred to you that software that does input and output on the Eclipse console would be useless for anything other than simple programs used to introduce students to Java, as I'm doing here. However, it is true that Eclipse and Windows 10 and 11 can be configured to accept input from and send output to the Windows command prompt screen. But it's a difficult configuration because Microsoft has deliberately made it difficult. Windows 7 shipped with the JRE and the JDK pre-installed and configured to download updates. Input and output on the command prompt screen was simple. But by the time Windows 10 came along, Microsoft and Oracle were locked in a bitter struggle for dominance, and Microsoft's C# is a direct competitor for Java. So the JDK and the JRE have to be downloaded and installed, as we did in the first 2 lectures. And the command prompt screen is now a difficult configuration. But even if it were easy to use the Windows command prompt screen, I wouldn't have bothered. Graphic user interfaces, GUIs, have been the default for a quarter of a century. And if you're going to work professionally with Java, you have to be competent with them. So, now is the time to start working with them, beginning with the simplest GUI, the simplest GUI, a dialog box. The dialog boxes we're interested in are small graphical windows that simply display a message to the user or display a message requesting input from the user. The JOption pane class can display a variety of dialog boxes, but like the scanner class, it's not automatically available to a Java program. If you want to use a dialog box, you have to write an import statement. This one, import javax.swing.joptionPane. Capitalized exactly as shown there. Now, while there are a variety of dialog boxes available in JOptionPane, we're primarily interested in these two: the message dialog box and the input dialog box. This line of code will display the message dialog box shown. The text within the quotes shown in blue, as it would be in the Eclipse editor, is displayed here. The use of the reserved word null requires a little more explanation. The show message dialog method, shown here in green and red boxes, actually has three forms. The one we're using here takes two parameters. The second one is the object message, the text string that is to be displayed. And the first is something called the parent component. That I've set to null. If I wish to redesign the frame of the message dialog box, perhaps change this icon or add a bright orange border, I can do that by creating a customized parent component using the techniques that are taught in the second semester Java. But if I don't want to make any changes in the frame, I just pass null. Null is a reserved word, which in this case indicates to the compiler that the default frame should be used. Now, as I've said, there are two other forms of the show message dialog method. The second one takes 4 parameters, and the third one takes 5 parameters. Now, this is probably your first encounter with the concept of overloading. 2 or more methods of the same class may have the same name as long as their parameter lists are different. And we'll look at overloading in more detail later in this semester, but for right now, when you write code using the show method dialog method, it is the compiler's responsibility to select from the 3 possibilities. But it is your responsibility to pass the correct number and type of parameters to ensure that the outcome is what you want. Okay, let's see if we can actually use the show message dialog method. Here's our message dialog. Lasciate agne speranza voi sciantre. For those of you who speak Italian, I apologize for my appalling enunciation. But do you recognize the message? It's Italian, of course, but the English translation is, "Abandon hope, all ye that enter herein." It's from the Inferno, the first part of Italian Renaissance writer Dante Alighieri's 14th century epic poem, The Divine Comedy. Inferno is followed by Purgatory and Paradiso, Purgatory and Paradise. The Inferno describes the imagined journey of Dante through hell, guided by the ancient Roman poet Virgil. In the lower left corner of this 15th century mural, tortured souls are passing through the gates of hell where this motto is inscribed. When I was 18 years old, I joined the Marine Corps and landed in Parris Island, South Carolina, where someone with a disturbed but accurate sense of humor had written this line over the barracks door. Now, we can insert a new line anywhere in the text to change the display to multiple lines, just as we did when we were outputting to the console. Okay, that's a message dialog. Now, let's work on an input dialog. The purpose of the input dialog is to obtain user input. So when the client types her name in the box and hits enter, whatever she typed should be read by the method showInputDialog and return to the string variable name. So let's try it in example 8.1. Add these two lines of code. Now, when I hit enter, I'll see the message dialog. And when I click OK, I'll get the input dialog, where I can type in Dante's name. Now, nothing will happen until the client hits OK, at which point the showInputDialog method will return the text string Dante Alighieri to the string variable name. Now, suppose at this point your client also wants her users to enter their age. Well, there should be nothing to it. I'll declare an integer, age, and write a showInputDialog to query the user. But I get a compile time error. And if I move my cursor onto the error, it changes to the pointing finger, indicating a hyperlink, and I get a type mismatch notification informing me that Java cannot convert from string to int. What's the meaning of that? Doesn't make sense, unless I look at the definition of showInputDialog box, the input dialog rather, by placing my cursor here and hitting Control plus space, which produces the usual red and green boxes. Now, remember, they won't show up on your Eclipse screen with the red and green borders. I added those to make it clear which boxes I'm referring to. And once again, I'm going to put my cursor on the slider in the green box, and then I'm going to draw it down. That is to say, I'm going to hold the left mouse button down and use the mouse to drag the slider down. And after I do that, I'm also going to enlarge the green box to make it easier to read the contents. So here we go. And right here is the showInputDialog method with one parameter, object message. Object is the name of a class. That capital O is a dead giveaway. But a detailed discussion of the object class, which is actually the foundation class for Java, will have to wait until we tackle polymorphism later on. But I do need to differentiate between the use of object with a capital O, which specifies a Java class, and object with a small o, which refers to any instance of any given class. In example 7.1 in lecture 7, I discussed creating an object of class scanner using the reserved word new to create the object. That's object with a small o. For any given class, a class like scanner, I can create instances of that class. And those instances are also referred to as objects. Objects with a small o. But here we're referring to the Java Foundation class. Object with a capital O. Now, if you find this confusing, you're not alone. But hopefully I'll be able to make it clearer once we've mastered the concepts that underlie polymorphism. But for now, we're simply going to assume that the showInputDialog method requires a string parameter here, and it will return an instance of an object with a small o of class string. Now, can you see the problem that caused the compile time error? What this means is that whatever the user types in will be returned as a string. So the problem is, I'm attempting to put a string into an integer variable, the variable age. You can't do that. You cannot assign a string to an int variable. And you can't assign an int to a string variable. The assignment operator requires that the data types on each side of the operator be compatible. So, what's the fix? Well, we could change this and this to this and this. So let's test this by outputting something that displays the user's input, something like this. So let's run it. Here's the output of the first statement. The text that's passed as a parameter will display in the message dialog box until the user clicks OK. When that happens, the next line, line 11, executes, displaying an input dialog screen. Like the messenger dialog, this screen stays up until the user enters his name, then clicks OK. Now, remember, at this point in the course, we're still assuming that all our users are really sharp, detail-oriented people. They make no input errors. They enter alphabetic characters when names are requested and numerics when the numbers are requested. Now, obviously, that's not the way the real world works. If there's any way to turn a software system to trash with entry errors, someone, sometime, will make that error, sometimes deliberately. So before this course is over, I'm going to have to teach you some defensive tricks to guard good data against garbage as opposed to garbage input. But not right now. Right now, I'm guaranteeing good data, no ambushes. So the user clicks OK, and the showInputDialog method retrieves the text that the user entered in the showInputDialog screen and assigns it to the string variable name. And this showInputDialog screen is gone, and now the next line executes, displaying a new showInputDialog screen asking users to enter their age. The user enters his age, clicks OK, and again, the showInputDialog method retrieves the string that the user entered in the input screen, the text character 5, followed by the text character 0, and assigns it to the string variable age string, and here's the output. We will inform your next of kin is printed exactly as in the parameter. The two characters 50, not the number 50, but the two characters 5 followed by 0, the string the user entered when queried for his age, followed by a second string, literal string, year old, followed by the string that is the name the user entered in the second screen. Now, that's the easy problem. But what the client really wants is something a little different. It turns out that in Dante's Divine Comedy, souls are sentenced to serve 7 times their age in the Inferno. So the sequence of screens, for example 8.1, should look something like this. The first 3 screens are identical to those we've already developed, but for the output, the program must multiply the user input age by 7. So here's our next task. Modify example 8.1 to get the output shown in red, the user's age times 7. So let's return to this point in the code where the show input dialog method returns the user's age entry as a string, not a number, but a string containing the character representation of a number. The documentation makes it clear that show input dialog will always return a string object containing the characters typed by the user. So, clearly, I'm going to have to find a way to convert the character string to its equivalent integer. If the user enters 50, representing the integer value 50, on this screen, and hits OK, the string of characters, in this case, 5 followed by the character 0, is assigned to the string variable age string. Age string does not contain the number 50. String variables cannot hold integers. They can only hold strings. Those strings can hold any or all of the characters 0 through 9. But that doesn't make the string an integer. It's still just a sequence of characters. But our problem domain requires that we calculate the product of the user's age times 7. So how am I going to convert a character string, in this case 50, to the integer 50 so I can multiply it by 7? Well, I'm going to have to dig an appropriate method out of the Java documentation. And the only reason I know where to look is that a long time ago, when I was learning Java, I stumbled across a set of classes which contain methods suitable for a wide variety of problem domains associated with the 8 primitives. We discussed, hold on, got a little ahead of myself. We discussed the 8 primitives in lecture 3. Here on slide 25 of that lecture, they're highlighted in blue. 6 of the 8 are numeric. The 4 integer types, byte, short, int, and long, and the 2 decimal types, double and float. The 2 remaining primitives are Boolean and char. Now, remember, these are data types, not classes. So let's revisit the difference between data types and classes. In example 7.1, first int is the variable name for a variable of the primitive data type long. I can assign it the literal value 0, but I cannot assign it the literal value 0.0 because that is a type mismatch. The compiler cannot convert from double to long because data type double requires more space in memory than data type long. So, assuming that first int has been correctly declared and initialized, or simply declared, the primary things I can do with it are assign it a value of the correct data type, which is what I'm doing on line 11, and use that variable name as a parameter, which is what I'm doing on line 12. And of course, all 8 primitives restrict the values that can be assigned to the variable of that data type. The integer numerics only accept digits and a leading plus or minus. The floating points accept those and a single decimal point. Booleans only accept the reserved words true and false. And chars will accept exactly one character enclosed in single quotes or the backslash combined with only 7 other characters. Now, contrast the primitives with the declaration of the reference variable keyboard on line 8. Keyboard is now a reference to an object of class scanner. That's scanner with a capital S. And that reference variable, which points to an object of class scanner, has access to all the methods of the scanner class, one of which is nextInt, which contains all the code required to get the sequence of characters entered by the user on the keyboard. A sequence of characters meant to represent an integer value and then convert those characters to their actual integer equivalent. Now, here's the core of our current problem. Show input dialog, a method of the JOptionPane class, doesn't work that way. It does not convert the user's entry from a string to an integer. Therefore, we need a way to convert the object of class string, age string, to its integer equivalent. If the user enters the character sequence 5 followed by 0, I need to convert that to the integer 50. So I can multiply it by 7 as required by the problem domain. Now, this is a common problem for all 8 primitive data types, and Java's solution is to wrap the primitive in a class with the same or very similar name. Here are the 8 primitives in blue with their equivalent wrapper class names in red. Now, note that the leftmost character of all 8 wrapper classes is capitalized, while the associated primitive data types begin with lowercase. Now, all the names are identical except for the primitive type int, whose associated wrapper class is spelled out as integer with a capital I, and primitive type char, which is spelled out as character with a capital C. All right, let's look at the documentation for all this. Go to the documentation page for package java.lang and scroll down to about here. Now, math class was covered in detail in Lecture 4, slides 173 through 189, and as stated in the documentation, the math class contains methods for performing basic numeric operations such as the elementary exponential, logarithm, square root, and trigonometric functions. And we'll be using it again, so you may wish to remember how to get to the math class. It's documentation. But right now, we're only interested in converting a text string that represents an integer into the actual integer value itself. And to find a method to do that, we're going to have to look at the wrapper class integer with a capital I. Now take a look at the peculiar language used to describe this class. The integer class wraps a value of the primitive type int in an object. The primitive data type int has no methods. It's simply a way to provide 4 bytes of storage to a sequence of zeros and ones. 4 bytes of zeros and ones that represent the actual numerical value of the integer in question in a binary format. But an objective class integer with a capital I has methods. And one of those methods, parseInt, will accept a string as a parameter and return the integer equivalent of that string. To find parseInt, click on integer to get the home screen for class integer. Now put your cursor on the scroller and scroll down to about here. Method parseInt parses the string argument as a signed decimal integer. Now, the term decimal integer simply means we're operating on integers to the base 10. If you work on complex problem domains, you will eventually end up dealing with binary, octal, and hexadecimal integer values. And if you look here, you can see that we can actually work with integer values with any radix. Now, let's click on parseInt and we'll get the details for that method. 7 of the 8 primitive data types have a parse method. It would make no sense for the character class to have such a method. And note that while the primitive type int is fully spelled out as integer for its wrapper class, the parse method once again abbreviates integer as int. And once again, we find the parseInt method as a common solution to the problem of converting age string to an integer. All we have to do is call the parseInt method, passing it age string, which in our example is composed of the characters 50. parseInt will convert that string to the equivalent numeric value. The result, in this case, a numerical value of data type int, can then be assigned to age, a variable of data type int. At that point, the problem's trivial. Multiply the age entered by the user by 7 and output the result. If you run the program with the inputs I used here, this should be your output. Okay, time for another programming problem, Program 8. This is an electron microscopic image of the first U.S. case of COVID-19. The virus itself is stained in blue. This illustration, created at the Centers for Disease Control and Prevention, the CDC, shows the ultrastructural morphology exhibited by coronaviruses. Note the spikes that adorn the outer surface of the virus. In a microscopic view, those spikes impart the look of a corona, like the corona around the sun. A corona surrounding the virus, as in the previous slide. The currently reported average diameter of the virus particles is about 125 nanometers. That's 0.60 followed by 125. But those measures have shown some troubling variances. Your company, Hurricane Island Research, has a contract to build a software prototype for the CDC that will query the user for the diameter in nanometers of 5 randomly chosen virus particles measured by a technician. Technician, using an electron microscope, will enter those values and your system will output the mean, the variance, and the standard deviation of the 5 sample set. So suppose the sample set looks like this. 5 samples whose COVID diameters are entered in nanometers. Then the sequence of dialogues displayed by the software should look like this. An introductory screen, 5 data entry screens, and display the results. Now, at this point, it might be reasonable to ask, what are the mean, variance, and standard deviation, and how am I supposed to calculate them? Now, those are good questions because in the practice of software engineering, it is not unusual to run into problem domains that require some understanding of the underlying physical and mathematical structures of the domain. Usually in very complex domains, you have one or more domain experts to assist you. But you're the one who has to translate that into code. And there are problems out there that are extraordinarily difficult to understand. Fortunately, this one is not difficult. The standard deviation is a measure of how spread out numbers are. Its symbol is the Greek letter sigma, the 18th letter of the Greek alphabet, shown here in red. And the formula is easy. It's the square root of the variance. So now you ask, what is the variance and how do I calculate it? The variance, sigma squared, is defined as the average of the squared differences from the mean. Now, that sounds complicated, but it's not. Calculating the mean is simple. Just add the 5 values and divide by 5. So let's look at it in the order we'd have to do it in the program. Start with the mean, and once you have that, then for each of the 5 samples, subtract the mean from the sample diameter, square each of those differences, sum the results, and divide the sum by 5. The number you get is the variance, sigma squared. Once you have that variance, the standard deviation is simply the square root of the variance, and in most real-world problem domains, it's useful to understand the purpose of the software system you're trying to deliver. In this program, the CDC is trying to establish the upper and lower limit of the diameter of COVID particles. But given the microscopic sizes, that's a difficult determination, and there are measurement errors that make the result suspect. What the standard deviation of sample sizes does is allow an epidemiologist to determine whether or not the COVID diameters in a given sample follow a normal distribution. Suppose we display this sample on a simple chart. I don't have to do this. It's not part of the programming problem. I'm just trying to give you a basic understanding of standard deviation. Now, let's employ the results of our calculations on my chart. The mean is here, and what I want to know is what percentage of the sample falls between one positive standard deviation and one negative standard deviation. Because if the diameters follow a normal distribution, which is the hypothesis that will be tested, then about 68% of the measurements should fall between 115 and 135 nanometers, 10 nanometers to either side of the mean. So, start with the usual basic structure, and once you complete your code, test it against some other sets like this one, where it is clear that the values vary widely from a low of 10 to a high of 150, and not surprisingly, the standard deviation is unacceptably large. Then try this set, where all data points are close to a mean of 124.6, which puts the standard deviation really close to 1, which means that all the samples are grouped closely around the mean. Now, you and I are not responsible for interpretation of this data. That's the client's problem. We're only responsible for writing software that accurately reports the mean, variance, and standard deviation of any set of 5 numbers. Now, once again, my strong recommendation is that you work this problem before continuing with these lectures. There's nothing here that I haven't already covered in previous lectures. I've given you 3 data sets and the correct solution for those sets. If you can't code a solution that produces those correct results, you need to go back over the previous lectures until you can. The material being presented will grow increasingly complex, as will the programming problems that will be posed to test your knowledge of that material. So here's what we've covered so far, and here's where we're going next.